Hello, this is going to be a quick overview of how Datadog, and specifically the Datadog agent, can integrate into an ECS Fargate configuration to send data up to one of your Datadog dashboards. So we're going to quickly begin by recapping how Fargate tasks work. Fargate tasks are an Amazon Web Services way to deploy containers. So maybe you have one container that holds your web app, your backend. Maybe you have another container that runs your front end. And maybe you have a couple of other containers, maybe one for pulling down remote images that pulls some website or database to supply data for your web app or front end to consume. It doesn't matter if you have many containers or one container, you can deploy any of them through ECS. So how you do this is by creating something called a task. So your task definition specifies which containers you want to deploy together. So if this were task 1 that had the web app container and task 2 had your front end, and you can define multiple tasks within a cluster, then the web app would always run on some EC2 instance. You wouldn't actually have to manage it. ECS Fargate would determine which EC2 instances it will be deployed on for you, and the front end will always be deployed on a separate EC2 instance. So within a task, though, you can define multiple containers, and by defining multiple containers within the same task, if this were, say, a single task that had both containers in it, then the web app and front end would always run on the same machine. And there's a protocol that allows them to communicate between each other, even though, as you've seen in previous videos, Docker has very strict controls about what information is actually exposed. So Docker does have something called a stats API, which you can see an example of on the left side of the screen, where you can query a container and get detailed stats about that container's memory usage, CPU usage, network information, etc. And that's largely what's exposed through Fargate, so that certain containers within a task can see information about other containers within the same task. So the Datadog agent it's a program that combines data and sends it up to Datadog for you. So maybe you have your web app and you have some Datadog agent running somewhere. The web app will send information such as stats, how long different methods are taking, what response codes were to APIs, whatever you want to configure in your web app to send over, and that can publish stats over to the Datadog agent. Now it sends that over UDP, and the Datadog agent collects those stats, and then every set time period, it sends all of those stats in bulk up to Datadog's web server. So Datadog has some web server, they have some database where they're storing this information that can then be displayed in your Datadog console. So from your web app, you can have arbitrary stats, APM stats, tracing stats. I won't go into those in this video, what you can all collect, but the idea of the Datadog agent is that it collects, it's a separate program, so it's not in your web app, it's a separate program that you can send stats to from your web app, so that you can eventually see it in one of your dashboards, or maybe you can get alerts if something's going wrong, if you want to track how many times a 500 error code is returned from some endpoint as an example. So how this integrates with ECS is actually pretty simple. So the Datadog agent gives you lots of options for how you install it. And one of the options is they actually have a Docker image hosted on their public Docker hub that runs the agent's code. It's up to date. You can specify versions by using different tags, etc. But what we're going to do is we're going to run the agent in the same task as whatever containers we want to keep track of. So this communication becomes fairly simple, and I'll show that through something called the task metadata endpoint. So as I mentioned before, containers within a task can use this ECS container metadata URI. There's some environment variable that's set on automatically on all containers within a task that lets them query data, that stats about other Docker images I showed you before. And it gives you, in addition to just the default Docker information that it gives you on their stats URL. You can also see, if you scroll down through some of the information it gives you any ports that are exposed by the container. And this is vital for how this communication happens. So there's two things there's two different kinds of stats that we care about. So the first kind of stats are things like things that we could get back from any Docker container. So this is things like CPU usage, RAM usage, so memory usage, network usage, all those kinds of things. We want to be able to briefly from our Datadog dashboard say, okay, well, how much of this memory we're allocating to our web app is actually being used. Because in a ECS task definition, you can say, I only want this web app to have, say, 512 megabytes of memory. And that's very small, obviously. That wouldn't be something you'd use in production. But you can specify how much you want. And then you might want to monitor how much of that is actually being used. So there's this endpoint that exists in the task. And the Datadog agent, just by default, even if you don't have any code in your web app that's related to Datadog or anything related to your Datadog dashboards, just by putting this agent in the same task, the agent can go to that endpoint and say, hey, what other containers do I have around here? Oh, I have some web app, and it won't necessarily know that it's a web app, but it'll see there's some other container and it maybe has a couple of exposed ports. That's fine. I don't really care about them right now, but it's going to say, okay, what's the CPU usage, RAM usage, etc. And then that, assuming that your ECS task has the ability to send requests outbound to the rest of the internet, depending on your VPC settings, it will send out to the Datadog servers information so that you can then go into your Datadog dashboard and say, okay, what was the CPU usage, what was the memory of my web app, or any other containers that you have defined in this task. But the second type of data that you care about are kind of more things specific to your web app. So maybe you want to have APM tracing, maybe you want to have dog stats D, which is a stats D implementation specific to Datadog. I think I have an example right here. Here's how you would use APM tracing. So this would be in Node.js, but it's very straightforward. You require this ddtrace library that you install via npm, and then in your JavaScript code, you just say tracer.init, and this works for TypeScript too. So this seems like magic. You just put a couple short lines in your JavaScript code, and all of a sudden you're getting detailed tracing information about which endpoints are being hit in your JavaScript application, how long it took for each of those endpoints to return a result. It gives you specifics within each endpoint, within each call, like within each function, how much time each subfunction took, so you can get really detailed information about where bottlenecks in your application are. But again, this code is super short. It seems like magic. So the whole point of this video is saying it's not magic. What actually is happening is when you call this tracer init, this library that Datadog has, it knows to check for the environment variable that tells it. It can just simply check for this ECS container metadata URI environment variable. If it finds that, it knows, okay, I'm likely in a ECS task or Fargate task. It can then go to that endpoint, query for other containers, find the one that's the Datadog agent, which it will know. It can check which ports are open. The Datadog agent Docker image will expose ports for things like stats and APM. I believe it uses different ports for each one. And then the web app, once it collects its information, can simply send UDP requests over to the agent to its exposed ports, and then the agent can send those up to the Datadog server. So it seems like magic, but all it is kind of querying this task metadata endpoint that isn't super prevalent in the documentation for AWS, but it's very useful if you're working on something like the Datadog agent. If you want to have a Sidecar application that runs along other applications, maybe you want something like Watchdog, maybe you want to use some security software like CloudStrike's Falcon or Amazon AWS Guard Duty and have that watch your app for security concerns. Datadog also has its own Watchdog. There's lots of different Docker images you might want to sidecar alongside your main applications. configurations. And in the end, this is always how this communication will work most simply. This endpoint is an intranet, so nobody else outside of AWS, outside this VPC, can access that endpoint. It's a secure way and in a very quick and efficient way for containers within the same task to be able to know which other tasks exist. So obviously, if you took the Datadog agent and put it in a task by itself and you left the web app in another task, that kind of configuration simply will not work because there's no longer any way to communicate. That endpoint no longer exists, and the agent would be useless. It could only track stats on itself. So they have to be put in the same task. The documentation, they do show an example of that. Here is the Datadog agent running alongside a Redis database. And for things that aren't like Node.js, for Redis as an example, you can just specify with Docker labels here, they show in their example, and that's how Redis then knows, okay, well, I should go and check the Datadog agent port 6379 to send over my stats. So that communication happens the exact same way. Thank you very much. I hope this clarified how different containers can communicate, and I hope you have a great day.